Hello and welcome to Homework 7.0, our first homework in the System of Equations unit. Alright, so let's see what we have here. Number 1 says, which of the following is the point of intersection of the lines whose equations are y equals negative 1/2 x plus 3 and y equals 2x plus 8? And then on the right hand side here, you're going to say use your calculator and number 2 from your 7.01 notes. So that's just kind of like a hint to help you how to figure this one out. So how do we use our calculator on one like this? So what you're going to notice is that both of those equations already have the y by itself. So we can kind of take advantage of that using our y equals button on the calculator. Because remember, when we're solving these system of equations, even though we're not going to graph them in this unit, we're still finding the point where those two lines intersect. So even though we're not actually graphing them, we're still doing the same thing. We're just going about it a different way. We're using algebra instead of kind of graphing techniques. Okay, but it hasn't changed. We're still trying to find where the two lines intersect. So on one like this, we could use our calculator. We could go y equals, and then we would type in the top equation, negative 1/2 x plus 3. We would type in the second equation, 2x plus 8. And then what we could do is we could look at our table of values. Now this is a multiple choice question, so we can go through the different options. Now option 1 is point negative 2 comma 4. So if we look at here, when x is negative 2, we're seeing both y1 and y2 are 4. So that's actually our right answer, but let's just look at some of the other ones so you can see what a wrong answer looks like. Number 2 is 4 comma 1. So when we go down to 4, y1 is 1, which is our first equation, but y2 is 16, which is our second equation. So that one doesn't work. If we look at 0, 8, all right, that's our third choice here. Well, when x is 0, our second equation is 8, but our first equation is 3. And then last but not least, the one 7, negative 2 there. When I go to 7, actually neither of the equations are negative 2, so that one's totally wrong. But basically, we're just looking for the point that the two lines share, and that would be negative 2 and 4, and that was the first choice there. And again, if you hit the graph button, you can see that our lines are actually intersecting there at negative 2 comma 4. All right, let's take a look at number 2. Number 2 says solve the following system of equations algebraically by using substitution. Check your final answer by using your calculator. All right, so again, we could just put these both in the calculator and find the answer, but we're going to start by doing it algebraically, and then we're going to check our answer using the calculator. So in this first one, we see that y equals 5x minus 12. So since that's what y equals, we're going to circle the 5x minus 12, and that's what's going to get plugged in for y down here. All right, we're taking this and we're making a substitution into the second equation. So now the second equation, instead of writing y, I'm going to write 5x minus 12 equals, and then here we've got the negative 2x plus 16. So I basically traded out this y for the 5x minus 12, and now I just have a regular equation that I have to solve. So let's move the x's to the same side. So that's going to give us 7x minus 12 equals 16. Opposite of minus 12 is plus 12. So that's going to give us 7x equals 28. Divide by 7, divide by 7. X is going to equal 4. All right. Now, the biggest mistake we see in this unit is kids do all of this work, they get the right answer, and then they forget to solve for y. All right. We're trying to find the point where the two lines intersect, so we need an x and we need a y. Now, I can plug this x into either one of those two equations. It's my choice. I usually pick the one that has less negatives going on. So I'm going to go with this 5x as opposed to the negative 2x. So y equals 5x minus 12. All right, I'm going to take this 4 and I'm going to substitute it in for x. So I get y equals 5 times 4 minus 12. So y equals 20 minus 12. So y equals 8. Right? So again, we didn't have to draw a graph, but if we did, if we had kind of our two lines here, what we'd see is that those lines are intersecting at the point 4, 8. That's what this algebra is doing. It's finding the point where those two lines intersect. And again, if we use our graphing calculator and put both of those in there, so if I type in 5x minus 12 and negative 2x plus 16, and then go to my table, you're going to see that when I scroll to 4, both the first equation and the second equation are 8. So that's the point where they meet. That's the point that they share, 4, 8. Okay, let's take a look at the back. All right, using substitution, find the intersection point of the two lines. All right, so this is just another practice of what we just did. So again, y equals 2x plus 5. So we're going to circle the 2x plus 5 because that's what y equals. And we're going to substitute it into the second equation here. So instead of having y equals 4x minus 5, I'm going to take this 2x plus 5. I'm going to substitute it in for the y, and then I'm going to keep the other side the same. All right, and now I have a one variable equation, so I can move the 2x over. Again, I usually like to move the smaller variable because it just means you're less likely to have a negative. This was a positive 2x, so we're subtracting 2x. I get 5 equals 2x minus 5. Add 5 to both sides. I'm going to get 10 equals 2x. I'm going to divide by 2. I'm going to divide by 2, and I'm going to get 5 equals x. All right, now the key is make sure you don't stop here. We've got to take this and we've got to plug it into one of our two equations. It doesn't matter which one, so you just pick whichever one you like better. I'm going to go with y equals 2x plus 5. All right, so y equals 2x plus 5. This right here is going to get substituted in for the x. So I get y equals 2 times 5 plus 5. So I get y equals 10 plus 5, or y equals 15. So again, what we just found is if these two lines were to intersect, they would intersect at the point 5, 15. That's what this is all about. It's finding where those two lines intersect. And then again, we could check this one the same way we've checked all the other ones. We could bring it up our calculator, type in the first equation, 2x plus 5. Type in the second equation, 4x minus 5. Bring up the table, so second graph. And then we want to check to see 5, 15, do the two pieces match? And they do. When x is 5, y1 is 15, and y2 is 15. Okay, that is it for today. Have a good one.